This lesson gives an overview and some examples of operations on sets. Sets can be added, multiplied, or subtracted. You can take the sum or union, U for union. Think of everyone being welcome. So everything in A, everything in B, and everything that's common is included. So union tells us that everything in A or everything in B. The product is actually called the intersection, the common part. Only those that are on both teams can be included. So that is an AND. So an element that is in the intersection must be in A and in B, not in A or in B. Then there's the difference, which is a not statement. A not B. So it's in A and it's not in B. So only those in one part can be welcome. Let's look at a few examples of this. Say you have A as elements 1, 2, 3, 4, B having elements 1, 3, and 5, and C having elements 5 and 6. Here are a bunch of examples to find. Now, one thing you might want to do is draw it out, especially if you have few numbers. So let's say A is here, B will be here, and C can be here. So what do we have? Well, A has 1, 2, 3, and 4, but none of those are in C, but 3 and 1 are in B. So 3 and 1 are in B, 2 and 4 are only in A, but B also has 5, but 5 is also in C, so it's common to B and C. And 6 is in C, but in nothing else. So when it's drawn out, it's a little easier to see. So A intersect B is what is common between A and B, and we've just identified that as 1 and 3. A not B, that means what's in A that's not in B. So 2 and 4 are not in B, but they are in A. A intersect C, so what's in A and C? Well, there's nothing in common, so you can say empty set. Or you can write set brackets with nothing in them, but do not combine them. A intersect B, intersect C. What is in common to all three of them? Nothing. So that's also an empty set. A union B is everything that's in A and in B. So we've got 1, 2, 3, 4, and 5. You don't need to repeat any elements. B intersect C. So what's in common between B and C? Well, 5's in common between B and C. A union B union C is what's in all of them. So 1, 2, 3, 4, 5, and 6 are all of the elements in all three of those sets. And finally, C intersect empty set. So what is common between C and a set of nothing in it? Well, there's nothing in common. So that's also an empty set. You could also have examples of sets that are interval-based, not element-based. So let's take a look at these. The first example has everything from -1 to 3, not including the endpoints. And the other interval says everything between 2 and 5, including the endpoints. Now they want the intersection, so the common part. So how do we draw the common part between those two? Well, if you fuse them together, you see that the -1 is here, and the 3 is here. So what's the common part? Well, only that part's common. So between 2 and 3 with including the 2 but not including the 3 is common, so you can write that as 2 to 3. Let's take a look at the next one. This one has the exact same intervals, but you're taking the union of those two. So let's take a look at that. We're taking from -1 to 3 unioned with 2 to 5. So everything that's part of all of those components. So that'll actually be all the way from -1 not including to 5 including, giving us -1 to 5. Let's try the next one. So we've got -infinity all the way up to 5 including, intersected with -3 including all the way to positive infinity. So the intersection is just the common part. So that includes between -3 and 5, including both parts. Next, we're going to intersect these ones. So -infinity up to -3, intersecting with -3 to positive infinity. Well, what's the common part? Well, it's just the -3. So you could just say -3 to -3, including both. Or you could say x's such that x's are equal to -3. Next, we have all the way up to -3 intersected with all the way up to 5, not including. Well, that intersection is just everything up to -3. And finally, we have a union between up to -3 and up to positive 5. So the union includes everything. So it's just -infinity up to 5.